Speaking about the learning process, well, there are two different options traditionally. One is batch learning, and the other is online learning. So batch learning is to use the dataset entirely for updating W. So learning can be summarized as evaluation of the model. In other words, you want to make some prediction based on your current W. And from here, you are going to measure error. So you have multiple instances. So you're going to take some aggregation of the error and then take some derivative of it and set it to 0. And this will give me how to update W. This is the basic outline how to update W during the learning process. And if you involve the entire data set you have, in particular, if you use entire training data to your learning process each time, that is called as batch learning. So all data instances available, they are used at the time of the learning. That means each iteration, you're going to look at all the data points and you're going to update W once. And again, you're going to look at all the data points, update your W once. But this is not an option for sometimes. So say you have 100 million of data and each data point is like few tens of megabytes. And somehow your memory is much smaller than that, so you cannot fit all the data points in the memory. So basically you don't have enough memory, or sometimes the data characteristic itself is stream data. So the idea is you cannot hold the entire training set on your hand. So entire training data set, DTR. So motivation is you cannot hold the entire training data set in your memory. In that case, where we are going to take another strategy, we are going to look at each data instance one by one. So look at one data point, update the model. Look at another data point, update the model, and so on. So that is called as online learning. So imagine there is a parameter and error space like this. So this is your parameter 1, this is another parameter, and this is the error function. So if you have multiple weight parameter for your model, you are essentially drawing a convex curvature in this multi-dimensional space. And if you look at this kind of curvature from top, so you're looking at this curvature from the top in this way, the diagram might be simplified in this way. So it's going to draw some contour like this. So batch learning can be understood from here to here. This is one update. From here to next point, another update, another update, another update, and so on. For each of these updates, you're going to use entire training data set. And obviously, you need to hold all the data points at end, so it requires a larger memory. But like you see, you can consistently heading to one direction. Maybe what you're looking for is somewhere over here, because we were going to go to the lowest point, maybe around in the middle. So in terms of the error, this is what we are heading to. And in terms of this contour, we are going to this center. So we are heading towards this direction sort of consistently. So that's the benefit of batch learning. So learning process is rather stable. Thinking about online learning, so you're going to look at each data point one by one. So one data point looks like this way, another data point looks very different from it, and so on. So you may expect some kind of fluctuation during the optimization. So again, the idea of online learning, you want to look at each data instance one by one to update the weight vector. So you look at one data, update your weight vector once, another data, to update weight vector one more time. Obviously, this requires less memory, but the optimization path is not stable like this. And this is something called the stochastic gradient descent. So if you played with PyTorch or TensorFlow, you may encounter with the optimizer named SGD. This is the acronym for stochastic gradient descent. And this is the idea. And modern machine learning, we have introduced some kind of a middle ground in between. So these days, most of the people are using something in the middle that is called as a mini batch. So we talked about two extreme. One is you have training data set. One option, batch learning, is to use the entire training data set. And online learning, you want to take one of the instance from DTR and update the W. We want to have some option in the middle. So you want to separate DTR in multiple groups. So we call that multiple mini batch. For example, you have 2000 example in DTR. Say you have batch size is 500. So each time you want to look at 500 data points and update W. Next time you want to see another 500 data instances and update W. And you're doing it again and again. So where you want to look at fixed amount of training data and update way back once. So while you're doing this, one of the important parameter is the batch size. How many data points will be involved in one batch. And obviously this is adjustable. So the memory requirement is also adjustable. And like you see in the diagram, in this illustration, the fluctuation is still there. But compared to the online algorithm, the fluctuation is much smaller. And we are still heading towards the center point steadily. So this is somehow very practical, and these days people use mini batch most of the times, especially with the neural network. And speaking of these stuff, where some of the important vocabulary is coming up. So batch size. This is the size of each mini batch. And you separated your entire data set, training data set, into multiple mini batch. That means, in order to use entire training data set, you need to go over multiple mini batch. So if you looked at the entire training data point once, that is called as one apple. So if you use the entire training data past, then you count that unit as one apple. And iteration is some kind of a multiplier between batch size and apple. So here comes the same example. So you start with the 2000 samples for training data. Say your batch size is 500, but you need to take 4 iterations to complete one apple. So we went over the basic idea of online algorithm and what we have studied, that is batch learning algorithm. So online algorithm or stochastic gradient descent, where if you look at the error function, so JWD, but basically the idea is the same. But this was from the batch algorithm. This should go away because here n is already 1. And we are using the same error function for online algorithm. So this is the updated one. So this is the error function JWD for a single instance. And based on this, same updating rule can be defined. So idea is again identical, alpha multiplied by the derivative. And this derivative again defined on a single instance. So if you expand it, you can calculate things in this way. So I is a column, and at the end of the day, it's going to be alpha multiplied by the difference and one of the observation value. So again, everything is the same, where only difference is you're looking at each instance one by one. And here, one of the important part is how to set alpha. So one of the option is where you can use a constant. So you are weighting each observation equally. But sometimes this is not good. So where as time goes by, where you may want to settle to some point in the parameter space. So maybe as you see more and more data, you want to reduce down the effect of update, effect of gradient descent. That can be set by using annulled learning rate. So by setting alpha according to n, so well, if you set alpha 1 over n, well, at the beginning of the algorithm, it's going to be 1, 1 over 2, 1 over 3, and so on. So the effect of each observation is big at the beginning, but it is getting lower and lower. And if you look at n minus 1th instance, each effect is 1 over n minus 1. And eventually the last instance, the effect to the model is only 1 over n. So you're going to lowering down the effect of each instance. That is the idea of annealed learning rate. So this is an algorithmic notation for online regression algorithm. And this again illustrating how the linear regression line is changing as you see each of the training instance. So at the beginning, it is making big jump if you use annealed learning rate. At the beginning, it is making big jump. Next round, well, still bigger jump, and next round still bigger jump. But the change is getting smaller and smaller as you see more and more data, and as you are getting closer to well, seemingly the answer. So well, that's the idea of this illustration. So well, that was just sort of explanation on online gradient descent algorithm or stochastic gradient descent algorithms.